I'm just so you guys can see what I did there. So I'm just gonna say new, and I'm gonna say new case one, uh, new case underscore one, and that's just the case right there. And you know what? I don't want this other case. Let's say, if you don't want this another, I'm going to use the name. You can see it says projects, but within the project you can have multiple different circuits, which you can run. So let's say if I don't want this particular case or circuit or a scenario to be part of my project that I'm working on, I can just right click it, unload it, and you can just completely get rid of it. So now we're in case one. One thing that I'm going to do here quickly, I'm going to go in view and I'm going to make this canvas a little bit bigger. So I'm going to go click canvas settings, come back over here, and I'm just going to make it bigger. And another thing I'm going to do is I'm going to just make the grids to display, so you can now see, all the grids in the back. Perfect. Going back. So what we wanted to do was, again, I'm just going to quickly erase this. As what we said, we wanted to have one voltage source, a resistor, voltage source, an AC voltage source, and a resistor. That's what we were trying to build. And we said this is going to be 2.0, or the resistor size is going to be 2 ohms. And then the AC source is going to be a 230 kV, 230 kV. Voltage line to line RMS, right? That's what we want. So I'm going to come back here and let's do that. So in this case, I'm going to go to master library, and that's where you're going to find a lot of these components. So you can see there's up here, these components exist, but really in that master library, they also exist as well. That's where master is where the stuff is, where the existing preloaded equipment is there. You will pick it up from here and you will bring it into your case. So for example, I need a voltage source at the moment. I'm going to go more and sources. I'm going to pick something very basic like this, and I'm just going to bring it right over here, zoom in. I'm going to go into, now you could see, now that I clicked into the sources, I need to go back to the master library. So I'm going to click home, up button. Now I'm back to the home page here. Now I want to go to passive elements. So the passive elements are basically the elements that don't require, external power to do their intended work. So let's say a resistor doesn't need an external power source to have resistance per se. But let's say, if you have a transistor, it requires an extra power. So then that's considered as an active, I guess, an active element per se. So let's go in passive. I'm going to bring in a resistor like that, and you could see now you can right click it, orientation, rotate it, or I just want to rotate it left, bring it in like this. Now this particular source is grouped with the ground source, so I want a ground source separately as well. So I'm just going to bring it right there. Now all I have to do is connect all of these items. So I'm just going to do that. So I'm going to go to what I did was I went to components, wire mode, and I clicked, and now I can click the other side, bring it, and like this. And now you can see one good thing about this canvas is that this is all orthogonal. You don't have to hold on to anything, just like in AutoCAD. Sometimes you have to hold on to a shift or a control to make it go straight up and down. That's by default. You can't really go across, and it kind of follows through these grids. That's why I turned on those grids earlier. So you don't need to be very artistic to make a very symmetrical circuit per se. Yeah, so this is our circuit right here, and now let's we want to make this resistor is very simple. So you double click it, you come in here, and you can just click 2.0, and you're done. And then now look at the impedance. I'm going to keep it again very simple. You can give this a source. I'm just going to say a name, my source. You can give it whatever name you like, or you can keep the default name as well. And we're going to keep an ideal source for now. We're going to say the start point is grounded, yes. And just so you guys are aware, you could also split it into 3-phase view as well. And then, but then you're going to have to do like 3 different then you're going to have to do a wiring for each phase. But to keep it simple, I'm going to double click it, keep it in a single phase. And now that single phase is this line, understands that it's connected to a three-phase system as well. And it gets, it becomes important at one point because there are in Pscad scenarios where you want to simulate single line to ground fault, so the fault is only occurring on a single line. So it's interesting. In those cases, you do need to split up a three-phase wire into a three-phase wire. We'll get into that. But let's first kind of go into this impedance again and go to signal parameters. What I'm going to do is I'm going to say, hey, I just want at the terminal. So if you'll notice, if I don't have the other option highlighted, this I can't really change anything in here. But if I click at the terminal, these particular fields become available. And now I can just say base MVA, I can set the voltage, but you know, just voltage is 230 kV. That's what I'm mainly interested in at the moment. We're not going to touch the rest of it just for now. As you could see, because I have clicked this to be an ideal source, none of the impedances are options are available to me, and that's it. And let's just press OK. So now I'm just gonna compile it just to make sure that things work. You can see now this became a more of a bold or a solid bold line here. It's compiling right at the bottom here. This is where the warnings and the messages are coming through. And yeah, so let's see here. So this is finished compiling, Pscad version this. So it looks like it compiled, no errors. And this little red button just means that, you know, I just need to save here. And the Workspace red button also means that I just need to save. Yeah. So okay. So now that we have our model built up with one source and a resistor, all what we need to do is simulate it. So I'm just going to click run and simulate, and you will notice something will happen that it's compiling right now. So every time you click run, it first again compiles. It's going to say finish compiling with Pscad version, and look, it didn't do anything. It just says EMTDC run completed. So it completed really fast. So what's going on? Oh, actually not just yet. So I'm gonna say allow. Let me just give me 1 sec here. I'm gonna give it a permission to run, and still you could see right here now for sure that the stop button and these that means the simulation is not running, and then the simulation is complete. Why the simulation completed so fast? We need to come into project, and you can look at duration of run. So the duration of run was only 0.5 seconds. Generally speaking, when we're performing any sort of an IBR testing or IBR model development, we set this to about 30 seconds run. That's how long generally speaking, your tests are 30 to 40 seconds. They could be 10 seconds depending on the situation or what you're testing. But just for the sake of this particular example, I'm just going to set this to 500 so I can make a point of what I'm trying to say. A solution step, Pscad is a time domain based software. Mean it is actually solving the time domain differential equations. So and it basically solves those equations every whatever step that you set. So which is quite common to have a anywhere between from a 10 to a 20. So I'm just going to pick a 20 for now. And channel plus step is more about how fast the graphs are going to be refreshed or calculated. So again, we'll get into that a little bit more. Not too concerned about that, but this one here more focused on that. This is basically 20 microseconds is that every 20 microseconds, Pscad is doing time-based calculations to tell you what the voltage is, what the currents are across the circuit. So I'm just going to go back here and click run, and let's see what it shows us. So again, I'm running, click run, and it's compiling again. Okay, so still it's not running just yet, so you can see both of these are on. So you will see that this will be, yeah, now this is not highlighted anymore. Stop is, these are the options that are available. So this means it's running, and this is a time of the simulation. This is not the time that is taking. It's saying we have simulated up to 178 200 seconds or whatever seconds, and this is how much percentage we're complete. So that percentage right here is really just the amount of time that you're at versus the duration run that you provided. So 500 divided by whatever time, that's the percentage that you're seeing here. And you can see it's very fast, but I'm not seeing anything. Let's say if I hover over this, you could see something. You saw as I hovered over this, things were changing. There were some voltages that were changing. But how do we view that data?